Right, going to heavy water. So you remember from the Batman film, this was where the penguin accidentally knocked the switch over. So instead of having drinking water, he ended up with heavy water. Now, what on earth is heavy water? Well, I have here 3 identical flasks. One of these is just an empty flask, and I'm going to set the balance to 0 for this. And in this flask, identical flask, with 100 millilitres of water, okay, so we've taken into account the weight of the flask, but we see that 100 millilitres of water weighs, well, it's just about 100 grams. Okay, that's the density of water is 1 gram per centimetre cubed, or per millilitre. Now, here I have some heavy water, and it's exactly the same amount. It's 100 mils, 100 millilitres of water, and this weighs 110 grams. Okay, so this is heavy water. Now, what exactly is heavy water? Well, in order to understand this, we need to look right into the heart of a hydrogen atom. So remember that water is made up of 1 oxygen and 2 hydrogen atoms, but we need to look inside this to see what a hydrogen atom actually looks like. What is it like? Well, if we looked inside, we would see the atom itself, the hydrogen atom. This is a normal hydrogen atom. There's an electron that whizzes round. Okay, this is whizzing around all over the place. This is negatively charged. And then in the center of the atom, in the nucleus, where all the weight of the hydrogen atom is, there's a proton. Okay, and that's what gives the hydrogen atom its weight. Well, a heavy hydrogen atom is a different type of hydrogen. It still has the same chemical properties pretty much as normal hydrogen, but this one still has 1 electron, still has 1 proton, and that's the thing that makes it a hydrogen atom. But this time it has a neutron as well, and the neutron has about the same mass as the proton, and this means that the mass of the hydrogen atom now, the heavy hydrogen, is actually twice that of a normal one. Well, remember, the water here is made up of 2 hydrogens and 1 oxygen. The oxygen hasn't changed, and so just replacing the normal hydrogens with these heavy hydrogens, sometimes called deuterium atoms, it means that the heavy water now, rather than weighing 100 grams, weighs 110. And this is actually rather interesting. I promised that I'd tell you why water is blue, and this is another really unusual thing about water. Now, most things absorb energy, and they absorb energy to make the molecules vibrate. Okay? So it's all to do with vibrations. Right, so imagine I'm a water molecule. I'm going to be vibrating. Okay? And I can vibrate in all sorts of different ways like this. This is how water molecules vibrate. And this actually, for most compounds, when they're vibrating away, they absorb energy in the infrared part of the spectrum. Okay? So most things absorb in the infrared. Well, that's enough of that. So here's infrared. This is infrared light. Everything when it's vibrating. So actually, maybe when you hurt yourself and you go to the doctors, they sometimes put an infrared lamp on, and it feels warm. It feels warm because it's making your molecules vibrate. Most things absorb in the infrared. Okay, so here is infrared. It's about here. And this is increasing energy. We've got all sorts of energy here. From radio waves, microwaves, infrared, visible, X-rays, really bad, gamma rays, bad. Okay, but most things absorb when they're vibrating in the infrared. Okay, now, so we need to look at vibrating molecules. I have over here a vibrating molecule. This is, well, just 1 hydrogen atom. Okay, and let's start this one vibrating. Here it is, vibrating nicely. And I have another hydrogen atom over here. And so remember, I have 2 hydrogen atoms in a water molecule. So here's another one. And I'm going to start this one vibrating, and if I can get it timed right, you see that it vibrates at the same speed. Okay, fine. Well, when I add the extra neutron to this one, watch what happens to its vibration speed. So let's stop this one and add the neutron on. So this is now making heavy hydrogen, or deuterium, and watch the bouncing rate now. Much slower, okay? And this is the point. So most things vibrate relatively slowly, like the heavy water does here, okay? But normal hydrogen and normal water vibrates pretty quickly. And it vibrates so quickly that it actually doesn't absorb infrared. Well, it does absorb infrared, but it also absorbs higher energy light, creeps out of the infrared and just absorbs red light. Anything that absorbs red light looks blue. Okay, so here is a blue filter. If I look through this, I can't see any red. No red light is coming through. It's been absorbed by this, and that's why everything looks blue. I can show this with my red laser here. Shining the red laser on this, the red light is stopped. It doesn't go through this. This colour here, this filter, absorbs red, and it looks blue. And that's what happens with normal water. Because it's vibrating so quickly, it actually absorbs in the red part of the spectrum rather than, as everything else does, in the infrared part, and this is why water looks blue. Actually, we have this set up down the bottom here, and you can come and have a look later. We have two tubes. One of them is filled with heavy water, and if you look through here, you will see that this actually looks white in the white light that we have at the other end, whereas the water, if you look through there, it really is blue. So water is blue not because of the sky reflecting on it when we look at a picture of the Earth, but actually because of the inherent vibrations of the water molecule. This is just another special thing about water. That's just about the end of the lecture. One thing I should say is I forgot to mention in all the haste here how you should put out an oil fire. So if ever you do have some burning oil, like we had here, you should never add water to this, because as we've seen, the water is instantly turned into steam and it sprays the burning oil everywhere. In fact, many homes have burnt down because of people trying to put out oil fires with water. Of course, what you should do is take a cloth, put it under the tap, wring it out, so you've got a damp cloth, and then just put this over the oil, and then that will suffocate it. It will stop the air getting to it, and it will put the fire out. I think we should finish with a bit of a bang. I hope you've had a good day, and I hope you've enjoyed the lecture. This is the reaction of hydrogen with the oxygen from the air forming water. Thank you very much indeed. Thank you.